Let's perfect the skill of identifying the subnet that a given IP address is on. This time we're given the address 24.194.3412/10. So let's go ahead and break that 24 down. We know that we can't subtract 128 or 64 or 32 from 24. But we can darn well subtract 16. So that would leave a remainder of 8, which just happens to be the next number. So we'll fill the rest of this out with zeros. And you got 16 and 8, 24, so we know we have that one right. Now, 194, we already know if we subtract the first two here, that total is 192 with 128 and 64. So we subtract that from 194, we have a remainder of 2. Here's the thing, though, about that. I don't want to really call it a shortcut because you've done the conversion you need. If you want to go ahead and break the rest of this address down for practice, I think that's fantastic, especially when you're first getting started. The more decimal to binary and binary to decimal that you do, the better off you are. However, since this is a /10 network, you have gone as far as you need to go. Because now to get the subnet that this IP address is on, all you need to do is add up what you have right there. That's it. So in that case, if you chose to do that, you would have the subnet 24.192.00/10. Again, just when they give you the mask like that, prefix notation, they've already done half the work for you. And to identify the subnet, all you got to do is break it down to binary to the length of that mask and then add up what you have. Again, even on exam day, if you want to go ahead and do all of that, break the whole address down, if you're more comfortable that way, fantastic, please do that. But I do want to show you the shortest and quickest way to get that done. Let's bring over 2 more examples. Actually, I think I mentioned 5, but we're going to do 4 here. And this one's a little bit different. 111.11.126.5, 255.255.128.0. So what is that in prefix notation? What is 255.255.128.0? It is 17. The first octet is all ones. The second octet is all ones. So that's 16 right there. And then 128 is, of course, your first value in the very next octet, the third one. So that is 1 bit. So you have a total of 17 bits. So this is a /17. So if we wanted to, we could just convert the first 17 bits of this address, 111.11.126.5, and then add up what we have, and that's our subnet. So let's go ahead and do that. We can't subtract 128 from 111, but we can do 64, right? And that would leave us 47, I believe. Then minus 32 from that would be 15. We can't subtract 16 from 15, but the 8, 4, 2, and 1 bits add up to 15. So let's check my math right there. 64, that's 96 right there. That's 104, 108, 110, 111. So there's your conversion for the first octet. 11, we can knock a whole lot of candidates out there. 128, 64, 32, 16, they're all going to be zeros. So we have 11 left right now. 11 minus 8 leaves us 3. So there you go. You've got the 821 bit set. That's total of 11 in your gold. Now, 126, we can't subtract 128 from 126. We come close, but we can't do it. So that's a 0. Right there, you've broken down the first 17 bits of this address. That's all you need. To get the subnet that this IP address is on, just add up what you have right there. You don't even have to go any further. So, what would that be? We know the first 2 octets would be the same, really, 111 and 11, and the rest of it is just zeros. So your mask, of course remains the same. Your subnet that this IP address is on is 111.11.0.0, 255.255.128.0, or /17, just depending on how they want to give it to you. Just that simple. Let's do one more. Let's do one more together, because just as a quick reminder here, of course I'm glad you're watching the videos, don't get me wrong, but the real key to mastering this is doing it. I know we say that so often it sounds cliche. Sometimes you just can't get hands-on with what you need to get hands-on with, and that's true of the CCNA. It's true of certainly more advanced studies. Maybe one thing you can't work with hands-on, but with this, With numbers, I mean, all you need is something to write with and something to write on. When it comes to subnetting, that's it. So this time we've got a little extra conversion to do because we got 210, 12, 23, 45, and a mask of 255, 255, 255, 248. So let's go ahead and break these down. We can use that practice. We know the first two numbers here are 1. That's 192. So that leaves us 18. 18 minus 16 leaves us 2. So we've got 192 plus 18 with those two numbers, and that gives us 210. So we have 12. Can't subtract 128, 64, 32, or 16 from those, but 8 and 4 is 12. And see, with practice, you're already seeing it probably differently than you were before. Because before, you're like, okay, I got to break down every number. You'll be able to look at 12 and say, okay, I know that's 0, 0, 0. I know that's the 8 and the 4 bits. So that's 0, 0, 0, 0, 1, 1, 0, 0. It comes with practice. 23 is going to be 0, 0, 0. We can subtract 16 from 23. That leaves us 7. And we know that 4 and 2 and 1 is 7. No, never mind. I was singing Beastie Boys there, but I can't afford the royalties. So let's see. So we got 24 bits. What is this mask in prefix notation? What is 248? That's 8 bits, 8 bits, 8 bits, 5 bits, right? Is that right? So that's 29. So we have to break down almost the entire address. 45, let's go ahead and break the whole thing down. Would be 0, 0. You can subtract 32 from 45. That gives us a remainder of 13. 0 for the 16, then 8, 4, a 0 for the 2, and a 1 for the 1. So that would give us 32 plus 8 is 40, plus 4 is 44, plus 1 is 45. So to get the subnet, what we need to do is add up the first 29 bits of this particular address. So we know it's all 3 of these rows, and then the first 5 right here, because that's your 248 mask. So that would be what? Actually just changing the last one. 1, 2, 3, 4, 5. Looks like 40 to me. Is that what you got? Because I could be wrong. Yep, that's it. 210, 12, 23, and then 40 right there, because it's going to be the first 29 bits. That's a /29 mask. And I know some of you are breathing a big sigh of relief. It's like, wow, this wasn't hard as I thought it was. There's nothing really complicated about finding this, using this particular operation. And you're going to find it's the same with the rest of the way. None of this is complicated. You just need a good explanation, and you need plenty of good practice. And that's the part you have to do on your own, although I've got some questions in my study guides and on Amazon, and I'll post some on the website as well for you. But that's really it for this particular section. So now we're really going to take all these skills we've used, the fundamental skills, and I'm going to show you how to determine the range of valid addresses for a subnet. Now we know how to get the number, but we need to know the exact range and the broadcast address for a subnet, and it's going to be the same operation. So whether they ask you either one of those two questions, which I know they will, you're going to use the exact same operation to figure it out, and I'll show you that on the next video. See you there.